Okay, so just using FOIL, working through that process, x squared, what did I say, outsides, minus 4x plus 5x minus 20. Okay, now it's just a case of collecting like terms, and by like terms, that means that, and this has to be the same. So that x squared is only x squared. The x terms, okay, so you've got plus 5 minus 4. Okay, so you're left with plus 1x. Remember, in algebra, we don't write it. We just put the 1, we just put the x. Okay, and then 20 is the only whole number. Okay, so should be nice and comfortable with that. Exact same process for b. Okay, 6x squared plus 4x minus 3x minus 2 plus x again minus 2. Okay, if anyone's not followed or if I pass by something and they want to question it, give me a wee shout. Okay, now this last question, question B, okay, is the most likely it'll come up style-wise. Okay, so you'll have a bracket in the front and then a 3-term bracket at the end. It's just the same process. It's a case of working with that first term, from 1, multiplying it with the second, multiplying it with the third, and then doing the same with the second. Okay, so that minus 6 multiplies with every single term in that second bracket. Okay, so the terms in the front bracket multiply with the terms in the second bracket. That's it. Okay, so 2x cubed minus 4x squared plus 1x, or I'm just going to put x. Okay, minus 12x squared plus 24x minus 6. Okay, so watch the signs, and then we're just collecting like terms. So the only to the power of 3, okay, is that one at the front. There's a couple of x squared terms. So there's that minus 12x and there's that minus 4x squared. Okay, so minus 16x squared. Okay, so just pulling this. Watch the sign. Okay, then the x terms plus 25x minus 6. Okay, so that's most likely, and that will be the question. Okay, so that will be 2 marks. Okay, so multiply that first term, multiply that second term, and go through it. Okay, so 2-mark question, non-calculator. Blitz that out of the way. Okay. Question 2. Okay, may have been a wee bit more challenging. Okay, we never did a lot of mixed numbers. So we looked at it, we went through a couple of techniques, but we never spent a lot of time on it. Okay, so hopefully you've had a chance to sort of digest it, look at the examples and work through them yourself. Okay, we'll have a wee look at it. So 2 4/5 plus 3 3/4. Now, that mixed fraction, that whole number in the front, okay, that's 2 whole sets of 5. Okay, so that's 2 whole sets of whatever the denominator is. Okay, so in this case, it's 2 whole sets of 5. Okay, so essentially that's 10 over 5 plus the 4 over 5. So 10 over 5 plus that 4 over 5. Okay, which will give you 14 over 5. Okay, so I'll just break that down and put that in the bracket. They don't look slightly different. What's that, sorry?
Sorry, I did that one slightly different, but I still got the right answer.
So I'll go through that. So there's there's another technique. And for the more complicated ones, it's a better technique. Okay, so I know what you did. Okay, so that's what that means. So there's two sets. So that's what that breaks down to. The same here. That just means 3 sets of that denominator, which is 4. Okay, so 3 sets of 4. I'll just put it like this. 3 sets of 4 is just 12. Over 4. 4 12. Plus your 3 over 4. Okay. So hopefully you're comfortable with what I've written out there. Okay. And with that, you can do your kiss smile. So we work mostly on kiss smile. Okay. Where we cross multiply and then we multiply the two terms and then we can join them together. What you need to do when you're adding and subtracting fractions, you need the denominator to be the same. Okay, so the denominator needs to be the same. Okay. So making the denominator the same. 40, 56, that would be over 20 plus 75 over 20. And you can see this gets quite messy, so the way Lauren's, I'm hoping has done it, okay, is better in this respect. Okay, that's quite a tough one. That's 131 over 20. And then you need to then break it back into the mixed number. So how many 20s go into that number? Okay, so 6 full 20s go into it. And then you're left with 11 at the end of it. Okay. Now what you can do when you're adding and subtracting, so we'll go back to the start and we'll look at a different technique. Okay, so we did a lot of that technique, but sometimes when it does get numbers quite high, like 56 plus 75, in a non-calculator, you can go down the wrong path. Okay, it's quite a tough one. What we can do is keep those mixed numbers in place. Okay, so I'm going to just write this out again. 2 4/5 plus 3 3/4. Okay, so we keep the whole numbers in place, so we don't do anything with these. Okay, we make the denominator the same. Okay, so we multiply that whole term, or both terms there, by the 4, and then we do the same process in this stage to make the denominator the same. We multiply it by 5. Okay, so we're multiplying both the 4 and the 5 by 4. Okay, so essentially doing the cross multiplication. Okay, so we're taking the whole numbers out of it, so we're sort of ignoring the whole numbers, and we're doing the kiss smile and just the two fractions. Okay, so the 4 over 5 and the 3/4. Okay, that means when we come back to it, we look at it like that, then we can just do, the whole numbers added together, which is 5. Okay, and then the fractions added together, which is 31 over 20. Okay, and then that 31 over 20 you need to break down, so there's one whole 20 in there, and then you're left with remainder 11. Okay, so you've got 6, 11 over 20. So walking through that might seem a wee bit more complicated to get your head round, okay, but it's actually easier to do. So what you're doing is just leaving, you're doing the kiss smile on the two fraction parts first. You're leaving the whole numbers where they are. You don't touch the whole numbers, okay? And then you add them both together. Is that what you did, Lauren?
Yeah, but I did it the first way. So I got 56 over 20 plus 75 over 20. But I cheated.
Okay.
I used a calculator though.
Oh yeah.
Just for that bit. Yeah, and then I got the rest. So yeah.
Alright, perfect.
If I wasn't using a calculator, I would do a chimney sum with that one to add it.
Okay, so go back to the first step. So you're doing 56 over 75. So don't be scared to ever take them to one side. Okay,
Yeah.
do that sort of different levels. Okay, so 6 plus 5, 11. Okay, carry the 1. 7 plus 5 is what, 12. 13, carry the 1. There's nothing else there, so 1, 3, 1. Don't be scared to ever take a sum to the side. Just make it really clear that's what you're doing, and then you sort of bring that back in. Okay, so get kind of comfortable with that, because there is sometimes sums in the non-calculator that on the face of it look quite difficult. Okay, especially when it's coming to decimals. So 3.14 is used a lot in the non-calculator. Okay, for when you're doing areas or parameters. Okay, so just be aware of that. So just being able to add quite big numbers, taking quite big numbers away, multiply and divide. Okay. Any questions on that, guys? Nice one. Okay, the part B was the same, but take away. Okay, so same process working through that. I got 2 and 7/12. Okay, so B, final answer, I got 2 and 7 over 12. Okay, and that doesn't simplify down any further. I won't walk through that, I'll just skip forward onto C. C was a multiplication, 5 over 6 multiplied by 1 and 3/7. Okay, same start process, so taking that whole number and multiplying it by the denominator. Okay, the denominator being the bottom number. Okay, so 5 times 6 is 30. We add that onto the top line. Okay, giving us 35 over 6. Multiplied by, there's a whole 7 over 7 there, so 10 over 7. Okay, so that 1 equals 7 over 7. That just adds in 1 there. Okay, so 10 over 7. Then that becomes 350 over 42. Now that's a big number. Okay. Perfect. Okay, so that's a big number as well. Now, there's two things you can do here. You can simplify this as much as you can at this point. Now, it's not an obvious simplification. Okay, so if I've got something like that in front of me and I can half both the numbers, then I do that. Okay, so I can half 350 because it's an even number, and I can half the 42. Okay, so let's just do that. Half of 350 is 175. Okay, half of 42 is 21. Okay, and that just makes it a wee bit more digestible. Okay, it's still pretty horrible, but it's a wee bit more digestible. Now I need to know how many whole numbers go into 175. So I need to know how many 21s go into 175. Okay, so I can remove that as a whole number. Okay, again, if it comes to it, just write it at the side. 21, 42, 63, 84, 105, okay, 126, 147. There's nothing glamorous about it, but it works. Okay, 168, and that would take us over. Okay, 189. Okay, so that's too far. So we're looking at that many whole numbers. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. 8 whole numbers takes us to 168. So we're left with 168 to 175, which is 7. Okay, everyone comfortable with that process? Okay, so we're 168 and we're left with the remainder of 7 over 21. Now, just be very careful. That can simplify down. So I can actually say 1/3. Okay. If you were really good, you'd be able to see that 7 at this stage goes into both of those numbers. Okay, but I wouldn't expect you to see that 7 goes into 350. Okay, without a calculator. Or in fact, I wouldn't expect you to see 7 goes into 350. Okay, so it just goes into 50 times. Just double check that. Okay, how do I know that? Well, you can actually just take away that 0. Take away that 0, you're left with 35. Goes into it 5 times, and then put that 0 back on 50 times. Okay. So 7 goes into that 50 times, goes into 42 6 times. You could have done it then, simplify it down even further. Okay, but I wouldn't expect you to have done that. Okay, so again, quite tough because the numbers are quite high. That's not uncommon. Okay, but if the numbers are nice, the numbers are smaller, then hallelujah. Okay, but it's the exact same process. Okay, very quickly, the divide. 3 5/9 divided by 2 2/3. Same first step. So 27 whole. So 27 plus 5 is 32 over 9. Divided by, so that's 6, so 8 over 3. Okay, remember when you're dividing a fraction, you change the sign and flip the last one. Okay, so 32 over 9 doesn't change, but we put in a multiply and we flip that last fraction, so it becomes 3 over 8. 7 times 5 is 35. 7 times 5 is 35. Yeah, sorry. Yes. Yep. What did I say? Is that what I said? Okay. So you flip that second fraction and then it's just a multiplication, and multiplication is quite nice. Okay, so that becomes 96 over 9 times 8 is 72. Okay, now 72 only goes into 96 once. Okay, 2 times 72 would be 144, so it only goes into it once. So left with 1, and then 72 to 96, you're left with a remainder of 24. 72. Okay, you'd want to simplify that down. So again, I don't see anything, in fact I do see something obvious. Okay, 8 goes into both of them. So 8 goes into 24 and 8 goes into 72. Okay, so it goes in there 3 times, it goes in there 9 times. And then I see a simplification again, 1 over 3. Okay, so don't be scared to simplify down in steps. Okay, so if you don't see anything obvious, okay, what I was going to do there was just half that. Okay, so it would be 12 over 36. Okay, so half that and half that to simplify it. Okay, so always look for either dividing it by 10, dividing it by 5, or halving it. Okay, make it more digestible for you, make it an easier number to work with. Okay. Any questions? Nah. Super. Okay, what was the other ones? Okay, so I asked you You might not have got this far, but I asked you to look at 3 and 4 as well, so let's have a wee think about it. A, it's quite easy, should just be taking out the common factor. B, I don't really understand. B, it doesn't really ask you much, but if you take out that common factor, I'll write it out, but it's not much there. D is actually something that would never come up in this exam, but I never said that. Essentially, you're taking out the common factor first and then factorising it. All right, so if you got to question D, then that's what you're doing there. Okay, so let's just have a wee look at that. I'll just write these down. Okay, so just x squared plus 4x. First thing I do when I see the word factorise, always write C dt. Common factor, difference of two squares, trinomial. Is there a common factor there? Yep. Take that common factor out. That's you factorised. That's it. Okay. It won't be that easy in the exam, probably. Likewise here, there's a common factor, so I think that's the extent of that question. Can you factorise that further?
That's the only answer that I got. I didn't factorise it any further.
Add together to make 0. Multiply to get 6. There's no such thing, is there? Yeah, that's a rubbish question. Alright. There's nothing you can really do with that. Okay. Part C. Question C, sorry. Was. Okay, now we're getting at trinomials. Okay. So, nice trinomial. Okay. We're adding together to make our second term. Sorry, I should have wrote CDT there. No common factor, no difference of two squares, trinomial. Okay, adding together to make our second term, multiplying together to make third term, which is plus 25. So the two numbers that we're multiplying together have to either both be positive or both be negative. Okay, just going through. That's it, isn't it? Okay, so -5, -5. Looks weird. That's weird. Okay. There we go. Again, quite a weird answer, but we'll go on up. Okay, so just a normal factorisation stages. Okay, so hopefully I'm good with that. I'm not looking at. Okay, and then the last one will never come up in this year's exam, okay? But if you're going to do it, you'd remove that common factor and be left with 3 outside the bracket, then you've got p squared plus p minus 6, and then you'd do the same process. Okay, so it'd be x plus 3 and x minus 2 would be your factors. Okay, so x plus 3, x minus 2. Okay, question 4. In this year's exam, you're only asked to do it rearranging, and it's if there's a root or a square in the question. Okay, so 4a would never come up. I mean, it's not a bad thing being able to rearrange that. Okay, you need to rearrange things like that anyway, so you might as well do it. Okay, but in this year's exam, what will come up is a root or a square being rearranged. Okay, so look out for questions, past paper questions like that. Okay, so have a wee go at that for a minute. Okay, and I'll come back on at 7:05 and we'll just go through that bit. Okay, just have a wee bash at that. Alright, so quite a tough one. So we're rearranging, I should have said we're rearranging for V, so the part in the brackets. Okay, so we're rearranging for V. Now we've got a root over that whole term. Okay, so that's the first thing that we want to get away. So that's not just an part of that that's rooted, that's that whole thing. So everything under that root, okay, is contained until we remove that. Okay, so it's not in a bracket, but just be aware that if it's underneath the root like that, then everything underneath that is contained by that root until we get that root away. Okay, so we need to remove that root to allow us to work with that on the right hand side. Okay, so let me just copy that down. Okay, so we're trying to get V. Okay, we're trying to isolate that letter V. Okay, so we're going to first step, move that root over. Moving a root over becomes a squared term. And then that releases the rest of that allows. Okay. Next thing we move across, okay, is either the U or that whole part in the bottom. Okay, so we can't just move the V at this point because it's got a add or a multiply in there. Okay, so we need to move the whole multiply or divide in this case. Okay, so this case the divide. Okay, we want to move that all over to the left hand side. Okay, so I would do it do that. Okay, which would allow me to move that whole R term over and leave us with that. Okay, now that's not the simplest root, or it doesn't look like the simplest root. Okay. So if I've lost anyone, give me a shout. Okay, so I'm taking that whole denominator and then moving that across, then bringing it back. Okay. Now, this doesn't leave us with something to isolate V with easily either, okay? Because we're going to end up with negative V. So there's a couple of next steps we can do here, okay? We can either run with it, okay? Bring that 1 across, turn it into a negative, okay? And then our next step would be taking that negative 1, taking it over here. Okay, that will change the sign on the other side. So that would become negative and that would become positive. Or just tidying that up. It would become that. Okay. Now, that doesn't look, again, the easiest way, so we could have written that out in a slightly different manner. Okay, so at this stage, okay, so I'll just write this out again. Okay, this stage we've got that. Okay, I want to isolate this v. Okay, as part of the question. Okay, I want that to be positive. So currently it's negative. Okay, but if I take it to the other side, it becomes positive. Okay, so I could do 1 equals u over r squared, positive v. And then I can move that whole thing there over and have 1 minus u over r squared equals v. Okay, and that's the exact same. Okay, so I'm left with the exact same answer. Okay, I've been left with v on that side. That's quite a complicated one because v starts in the bottom of a fraction. Okay, so there's a few different places to get lost there. Just keep working with your rules. Okay, so if you're unsure on rearranging, just have a look at that because there will be a rearranging that has to be done. Okay, there will be something that will need rearranged. Okay, and it will have a square or a root in it. Okay, is any questions on that one? Okay. If you're uncertain, just go straight back to basics. Okay, just look at rearranging of linear equations and just work your way up to something like that. Okay. Okay, working through 5 and 6. Again, straight line stuff, really common, so expect straight line to come up. Question 5 is just looking for the gradient. So I signed off just before the break, just showing you the equation of straight line again. Okay, so y equals mx plus c. So y being the y coordinate, x being the x coordinate. Okay, those two axes. M being the gradient and c being the y-intercept. Okay, so where it cuts the y when x is equal to 0. Okay, so if we are working with something to 2x minus y equals 1, we want to get it in the format of y equals mx plus c. So we have a number in front of x, okay, and then y is isolated on its own. Okay, so we want a positive y as well. Okay, so we want y on its own and we want x with a term in front of it. Okay, not necessarily, it could be a gradient of 1. Okay, whatever that term is. So people will see quite quickly what's going to happen here. Okay, but the important part here is we get y as being positive. Okay, so I'm going to move y to the right hand side. Now that's counterproductive what I've said. Okay, but now it's positive. So now we just want to isolate y. So we bring that 1 over to this side. Okay, now remember with that equal sign, just like a seesaw, so the left hand side equals the right hand side. So I can just flip that around and it'll be the exact same. So y equals 2x minus 1. Now it's in that format, that form that we want. Okay, y equals mx plus c. Okay, so the gradient in this case is equal to, if it asks for the y-intercept, Just like any of the graphs that we do, this happens when x equals 0. Okay, so substitute that in, place that x. Okay, so your coordinate would be for your y-intercept. Okay, so your y-intercept is always when x on the horizontal is equal to 0. Okay, so where does it cut through? Okay, gradient, so what I asked for in that question, it's just that number in front of x. Okay, but we want to get it in that form, y equals mx plus c. Okay, second one, what was that third y? Oh, sorry, x minus a third y. X minus 1/3 y equal to 0. Okay, don't let that 0 put you off. Okay, rearrange it to get y is a positive on a different side than x. Okay, so we move that whole term over here and it becomes a positive. Okay, I'm going to do the old switcheroo. Get the y on the left hand side, x on the right hand side. Okay, again, nothing's changed in that seesaw. It's still the left hand side. I've just made the right hand side, I've made the left hand side. So no sign changes. Okay, really, really important. No sign changes when I do that. Just taking that and flipping it. Okay, like a seesaw. Then I can take that 1/3, move that over there. Okay, and then our gradient is 3. Okay, so remember the gradient's how steep it is. So the gradient is 3, so m is 3. It means it cuts the y-axis at 0. Okay, so don't be put off the fact there's no plus something or minus something. It just means that just means it cuts the y-axis at 0. So when x equals 0, y is equal to 3 times 0, y is equal to 0. Okay, so your coordinate will just be 0, 0. So don't be thrown by that, don't be put off, don't be worried by that. Okay. Question 6. Question 6, sometimes quite tough to see where we're going with this. Okay. The first two questions, so A and B, you need to factorise first, both the top and the bottom, and then cancel out. Okay. So you need to factorise this, do CDT, and likewise you need to factorise this, do CDT. Okay. Now that top one, it might be difficult to see because there's no number involved, okay? But what that is just the difference of two squares. Now the difference in two squares, when we get it, we just separate, it's a plus b, a minus b. Okay, then the second one, we're just taking out a common factor. Okay, now at this point, because the top line is bracket multiplied by a bracket, and the bottom line, the denominator, is a number multiplied by a bracket, we can cancel out. Okay, so that a minus b and a minus b, they cancel out, the one in the top and the one in the bottom. Okay, and that just leaves us with a plus b over 2. Okay, second part B, pushes your factorising skills even further. Okay, pushes the factorising skills even further. Okay, so you want to deal top line first, the bottom line, and then bring them back together. So dealing with that top line first, I'll just write it out fully. Okay, and we've got something like that. CDT, there's no common factor, there's no difference of two squares, so it's a trinomial. Okay, now it's a tough trinomial because we've got that number in front of the x squared. Okay, so remember how we're dealing with that. We add two numbers together to make 1. Okay, and we're multiplying two numbers together to make negative 12. Okay, where does the negative 12 come from? Your 6 multiplied by your negative 2. Be careful of the sign. Always watch out for that sign. Okay. Has to be a plus or a minus. The minus and a plus. Okay. 1, 12, 2 and 6, 3 and 4. Okay, no other factors. Which one of them could give us a positive 1? 4 minus 3. Okay. So remember the method I do, we then put that into brackets. 6x plus 6x minus 3, 6x plus 4, divided by whatever number's in front of that x squared term. Okay, then we're tidying that up by taking out common factors. Taking out a common factor there. Taking out a common factor there. 3x. Tidying that up, that term and that term multiply together. That means those two terms cancel out. So we're trying to cancel out that bottom term. Okay, and that leaves us in our fully factorised form. Okay, so that's that top line factorised. Okay, we've still got that bottom one to deal with. Okay, the bottom one was 4x squared minus 1. Okay, 4x squared minus 1. What'd be quite difficult to see here is that actually the difference of two squares as well. Okay, that first term is a squared term, it's just 2x squared. Okay, and that second term, number 1, is also a squared term, so 1 times 1 is 1. Okay, so that is the difference of two squares. Remember the difference, you just need a takeaway in the middle there. Okay, so that just gives you 2x plus 1, 2x minus 1. Okay, so that's quite difficult to see, something like that. Okay, so be careful. Write out your CDT. Just work through that process. Is there a common factor? No. Is it a difference of 2 squared? Okay, well, 4 is a squared term and x squared is a squared term. So that whole thing's a squared term. Minus, yep, and 1 is a squared term. Sometimes quite difficult to see. Bringing them back together. We've got 2x minus 1 on the top. Multiply with 3x. And then the bottom, we worked it out to factorise form. Okay, and that means that, and that cancels out. Okay, we've got the same bracket on the top and the bottom. It gives us 3x plus 2 at the top, 2x plus 1 at the bottom. And that doesn't cancel any further. Okay, so a lot going on there. Okay. Be surprised because they're not combining different methods, I'd be surprised if you got something like that. Okay, but there's no reason you couldn't. Okay. Okay. Okay, so C and D is a wee bit different. C and D, 2a plus 3 over 4 plus a minus 1 over 2. Okay, this is just working through our kiss smile. Okay, so we're adding two fractions. Okay, just because we've thrown in a couple of letters there doesn't change the way that we work with these. Okay, so what we're wanting to do is make the same denominator. Okay, so there's two different ways you could do this. Okay, but I'm just going to do the kiss smile and stay consistent with what we've been doing. Okay, so multiply these two terms together. Okay, multiply those two terms together. Oops. And divide by those two terms multiplied together. Okay. And then it's just a case of breaking up those brackets. Okay, and then bringing it together. And then we could simplify that. Okay, so we can take out something like that. 8a plus 1. Okay. That goes into that once, goes into that 4 times. Okay. So we're left with 4a plus 1 over 4. Okay, so we're just tidying that up. But we're just going through our kiss smile. So when you see that, just work through your kiss smile. Okay, so algebraic fractions still in there. Okay. Likewise, part D, question D. Oops. 4x plus 1 minus x minus 1. Line through this, 4x minus 1 minus 2. Remember, when you've got that, you don't need to break the brackets in the bottom because they're already in their factorised terms. So you need to put it in that form to be able to cancel out later on. Okay, so you don't need to do anything with the bottom. You don't need to break that bracket up. Just tidy up top. Okay, that bracket down, or that bottom stays the same. Is that right? No. 4x minus 2x is 2x. And that's x plus 1. Okay, take a common factor out. Don't think it does anything, does it? 2x minus 3. No, it doesn't do anything. Is that right? 2x minus 6 minus minus minus. x minus 1, x minus 1. Yep. Okay. So I'd usually expect a wee cancellation about here, but nothing's happening, so. Okay. Happy with that, algebraic fractions? Okay. Just showing what we've just done. Okay, so we did a bit of FOIL, we did a bit of 5.11, done a bit of factorising. And then your algebraic fractions. Okay, so all your section 8 stuff. Okay. So none of that's been removed, so all that's in. Okay, but that's what we've just worked through this year. Okay. Okay, question 7, don't do. What's the time? 8:10. Right, let's have a wee look. Let's do. Jesus Christ. Let's do question 9. Okay, so question 8 is just straight lines, so you should be able, or if you look at that, okay, so look at question 8, you'll be able to do that. Okay, that's just your straight line stuff. So y equals, to find your gradient, you would do x2 plus x1, y2 plus y1, divide them. Okay. Question 9. Let's have a wee look at question 9 and 10. That'd be good. Okay, so have a wee look at it, guys. No split item. No. Okay. I'll just zoom into question 9 and give you 5 minutes just to look at that and see if you can make sense of it. Okay. So going through your rules for angles within a circle. Okay. Have a wee think about that, and I'll come back on at 1:15.
Your mic's off, I think. There we go.
Thank you. Okay. All that good explanation as well. All right, so what we're saying, line PL cuts right through the middle, cuts through the centre O, indicated here. So it's the diameter, okay, side to side. Any two lines coming away from that diameter and meeting at a point on the outside edge, okay, it's going to create a right angle. Okay, so that's one rule that immediately springs into my head. Okay, so that angle in there, it's going to be a right angle, and that angle in there, it's going to be a right angle. Okay. What else do we have? Well, we've got the fact that P and L and then M and M creates a tangent. Okay, so the tangent MN, okay, so M to N, that tangent in that PL line creates more right angles. Okay, so that tangent creates a right angle. So there's a right angle here, there's a right angle there. Okay, what does that allow us to find? Well, it means we can find that angle in here. Okay, mark with whatever you want. That angle in there is just going to be 90 minus 47. Okay, so it's going to be 43. So that angle in there is going to be 43 degrees. Is that right? Yep. Okay. Now, all angles add up to 180, so we can also find this angle in here. Call it A, whatever you want to call it. Okay, that angle is going to be 180 minus 90 minus 31. Okay, so 180 minus 90 minus 31 is going to be 59. So that angle in there is 59. KLJ.
How is it 180 again?
So all three angles in the triangle add up, any triangle add up to 180. So that triangle created by P to L to K, then back, adds up to 180. So this angle here, plus the 31, plus that angle there, adds up to 180. Okay. Oops. So that angle there, that angle there, that angle there. Does that make sense? That help?
Yeah, thank you.
Okay, so what are they looking for? They're looking for angle KLJ. So starting at K, your angle is the one in the middle, L. Okay, so that's the angle here to J. So your start, middle, finish. So they're looking for that total angle. So they're looking for our 59 plus our 43. Okay, so 59 plus 43 is 102. Okay, so that angle would be 102 degrees. Okay, so remember, if there's a diameter, so in this case P to L, and two lines come away from that and meet at the outside edge of the circle, that's going to create a right angle. Okay, so there's a right angle created at PJL, and there's a right angle created at PKL. Okay, where a tangent hits and meets a radius, or in this case a diameter, but a radius from O to L, that creates a 90-degree angle as well. Okay, so look for your 90-degree angles. Okay. Remember, diameter and chords you work differently with, so make sure you're comfortable with chords as well. Okay, so let's clear that. Okay, let's have a wee look at this one. Okay, so they like questions like this, where you've got a shape, and you have to come up with an equation for it. Okay, so they can ask this for quadratics. Okay, they like a quadratic using this, or they can ask it in this case for surds. Okay, and we'll go through how that works. Or they can ask it for simple algebra. Okay, it's just when there's letters involved. So there's quite a few different ways they can tell a wee story here. So this one, question 10, what they're looking for you to do is calculate the value of x. So come up with an expression that shows x, okay, using what you've been given here. Okay, so we're given a square side with centimetre with each. We've been given a square with each side being x centimetres long. Okay, so x, and then there'll be x there. So they've not put that other side here. Okay, and has a diagonal of 6 centimetres. So we've been given the diagonal. What that's created, see there's a right angle triangle. Okay, so that's created a right angle triangle. So they're looking for you. I'll just draw it out. 2 seconds. 2 seconds. Is that sitting like that? Right. Okay, so we've got that. But that side is 6. That side is x. Because it's a square, that side is also x. Okay. So, right angle triangle, I want you to come up with an expression for x, work out what x is. Okay. So right angle triangle, you're using the rule a squared equals b squared plus c squared. Okay, now some people write that out differently, so I'll write it out fully. It's long side squared is equal to the 2 short sides squared. Okay, so put in what we know. Well, the long side is the hypotenuse, 6 squared. Short side is x centimetres long plus x centimetres long. Okay, squared. 36 is equal to x squared. So they're asking for it in terms of x. So you want to isolate x. So we want to rearrange that to end up with x on its own. Okay. So you want to move that first. Okay, so you've got 36 over 2 equals x squared, or what's that, 18 equals x squared. And again, you want to leave x on its own, so you're bringing that squared term over to get root of 18. Okay, now for simplicity, I'm just going to flip this. Okay, so x is equal to root 18. Okay, so I'm not changing the side, changing sign. Okay, I'm literally just turning it round so it's easier. So the x is on the left hand side. Okay, now it's a case of simplifying down that third. So knowing your rules as thirds, very important. So 9 times 2 in this case. Okay, and we can break that up into root of 9 multiplied by root of 2. Root of 9 becomes 3. Root 2 can't simplify down any further. So x equals 3 root 2. Okay, so we've got an expression for x, and it asked as a simple surd as possible. Okay, so that's a simplified surd. Okay, so they might throw something at you like that, so there's no reason they can't do that.
What does this come under? Like, what topic's this?
That, good question. Let's have a wee look. Okay, so it sort of combines a wee bit. So there is a wee bit, obviously Pythagoras there, but they've thrown in surds. Okay, so there's a wee bit of surds going on, which is this topic here, topic 2. Okay, they've thrown in a wee bit of Pythagoras. Gradients, blah 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 blah, straight line functions. Okay, bit of this forming equations. Okay, so this forming equations 14.7. Okay, so it was a wee bit of forming equations, it was a wee bit of Pythagoras, and it was a wee bit of surds. Okay, so they like a question like this. Okay, the perimeter is equal to 40 centimetres, work it out from there. Okay. I think forming equations is probably one of the toughest parts. Okay, seeing where they come from. So they like doing it for quadratics, and they like doing it for just algebraic sort of equations like this setup, and the one I just did. Okay, simultaneous equations, not so much. but they like doing it forming quadratic equations. Okay, like so. Okay, and we'll go through a couple of them over the next few weeks as well. Okay, so forming equations. So you need to take data off a picture and just put it into a form and work it out, solve it. Okay. So it sort of jumps between a few. Okay, so that's the sort of non-calculator example. Okay, so don't do question 7. But other than that, I think the rest were okay, weren't they? Okay, so don't do question 7 at all. You don't need to rationalise the denominator. Didn't do the straight line, but have a wee look at that. Okay. Calculator paper, so we've got half an hour, so let's pick one. Right, in fact, I'll go through the questions you don't need to be able to do. Okay, so in the calculator paper for this worksheet 1, you do not need to know how to depreciate, you don't need to reduce. Okay, so don't do question 1. Question 2 is volume, do that. Question 3 is standard deviation, you need that. Question 4 is the quadratics. Okay, they've just put it into a wee story. All you're looking to find out is where your roots are. Root, and calculate the height of letter A. That height is just your turning point. Okay, so it's just your turning point. So where is your turning point? That is your height of that letter. Okay. Arc. That's fine. That's fine. Appreciation, you do need. Okay, so question 7, you do need. And question 9, you do not need. Okay, so don't do question 9. So 1 and 9 in the calculator part, you do not need to be able to do. Okay, the rest you do. Okay, so how about, because we had a wee go at the chord question the other day in class, some of us struggled a wee bit. Okay, let's have a wee go at this. Okay, so the diagram opposite shows a circular cross section of an oil tank. In fact, it's an oil tank, doesn't make any difference. Okay, we've got a circle, we've got a chord PQ. So a chord is just a straight line that touches the outside of the circle. We've got a radius from your center of your circle to the outside edge. Okay. O, center of circle, PQ, surface of the oil. PQ is 3 meters long. Okay, so that's drawn on the image. And the radius OP is 2.5, so it tells you it's a radius. Find the depth D. Okay, so have a wee go at that. Let's call it 5 minutes. In fact, have we go at question 6 and 7 if you can. So population is increasing at 2.4. Okay, yep. So have a go at question 6 and 7. Let's say 10 minutes. I'll come back on at 22. Okay, and we'll go through it. Okay. Okay, slightly different way of looking at lines in a circle, okay, and working out angles, etc. So we've got a chord this time, okay, so that line PQ represents the oil surface, okay, so P to Q is a chord, okay, a straight line side to side. O to P is a radius. Okay, that means if we bring our line straight down from O, okay, we're going to cut that chord in half and we're going to create a right angled triangle. Okay, so that chord length was 3 meters. So if we cut that in half, we're left with 1.5 and we're left with a right angled triangle. Okay, that's what we need. That allows us to find this side here, that I'll call X. With that side, we can see what's missing from the radius. Okay, that leaves us with d meters. Okay, so let's draw this out just so we're clear. Okay. Okay, so we've been left with a right angle triangle. It doesn't look like that. Okay, so we've been left with that right angle triangle. The hypotenuse is the radius, which was 2.5 meters, and the bottom length is got the bottom side is going to be 1.5. Okay, so we've got hypotenuse of 2.5 and the bottom of 1.5. Okay, and this is our missing side here, X. Okay, that X. Okay, so that's our sort of start point, so our rules. So when we're looking at chords, we're looking at creating that right angle triangle. Okay, we just use Pythagoras again. Okay, and this time we're looking for a missing side, so we're missing a short side. Okay, so remember that's long squared equals short squared plus short squared. Okay, long squared is your 2.5, that's your hypotenuse. 1.5 squared plus our missing side, which is x squared. So we just need to rearrange to find x. Okay, so bringing that 1.5 over to the other side. Okay, that leaves us with 4. I'll just flip that so it's tidier. Okay, moving that square to the other side becomes a root, so x is equal to 2. Okay, now that's not the end of the question. That's us only found that triangle, the side of that triangle. What's the question that's looking for? Okay, what have we just found out? We've just found out that length in there. Okay, that's 2 meters. Now it's asking for this length, so it's asking for surface, top of the surface to the bottom. Okay, now what's that 2 meters plus that d meters? Well, that's just a radius. So we know what the radius is. We know the radius is 2.5. Okay, so O to the top of the surface is 2 meters. That means that d meters must be just 2.5 minus 2, must be 0.5 meters. Okay, so that must be 0.5 meter. Okay. Last question of the night is a percentage question. So remember, you're just looking at appreciation or increasing. Okay, that increase percentage. Okay, so population starts at 528. Okay, so 528,000. and it increases at 2.4% per year. Okay. So 528,000. Okay, it increases at 2.4% per year. So when you're looking at a percentage question of that, we're looking at creating something called a multiplier, remember? Okay, so we're looking for that number to increase. So the multiplier has to be a number greater than 1. So if the number's smaller than 1, that number will reduce. So the number has to be greater than 1. So our multiplier here is going to be 1.024. Okay, that 0.024, that's your 2.4%. Okay, it's just that number divided by 100, and then we're adding it on to 1. So after 1 year, okay, we've got 528 multiplied by 528 sorry, 528,000 multiplied by our 1.024. Okay, which gives us 540,672. Now we could do that every year. Okay, we could then multiply that by 1.024 for year 2, then again 1.024 for year 3 and year 4. With 4 years, that's a reasonable way to do it. Okay, it's quite a relatively short period of time, so you only need to do that calculation 4 times. Now the quicker way of doing it, okay, is putting in your calculator 528,000 multiplied by your multiplier, and you're doing it to the power of 4. Okay, and that will give you your answer. Okay, so you're putting that multiplier, the 1.024, and you're doing it to the power of, or putting an index in for how many years or how many periods of time. Okay, so if you put that in your calculator, you're getting 580,542 out. Okay, or 541, 541, 542. Okay, now they ask for it to the nearest 1,000. Okay, so they'll always ask for it to the nearest 1,000 or to the nearest 100 or to 3 significant figures. Okay. That's what we're looking for. Okay, so again, that looking at appreciation, which is somewhere. Way down the bottom, yeah. There we go. Okay. Appreciation. So calculate the multiplier as a decimal. That was a 1.024. Okay. And then that's the last part we did there. Okay.
Is that question normally in the calculator or the non-calculator question?
Calculator. For the simple fact, you need to, well, multiplying by a decimal is quite hard to do, but if you need to do it to the power of something, that's almost impossible to do without a calculator. Well, it's very difficult to do without a calculator, so they won't ask you to do it. So that will always be in the calculator paper. Okay, guys, so that was worksheet 1, okay, of that mixed questions. And we were working on section 15, wasn't it? Section 15, okay. So these mixed questions, exam revision 1. Okay. So I'll walk through that. So these, I don't see any answer sheets for them. That's why I've picked them to do. Okay, so you've got the answers for them. But they're quite good worksheets. Okay. If you do want something with the answer, what was it, section 9, okay, that breaks it down. So there's questions and answers in section 9. I think it was section 6 as well, I said, wasn't it? Section 6 has exam papers, so the past papers with the marking schemes, and section 4 has exam past papers but broken into sections with the answers. Okay, so 4, 6 and 9, questions, answers. Section 15 is what I'll go through. Okay, any questions, guys?